So we have done sp3 hybridization. Now I'll do sp2 hybridization. How sp2 hybridization takes place in atom. sp2 hybridization means it mixed up of one s orbital and any two p orbitals, any two p orbitals means, as you know, there are three p orbitals. One is said to be px, another is py and pz. So it can mix with py and pz, it can mix with px and py, any two p orbitals, to give three sp2 hybrid orbitals. sp2 hybrid orbitals. So 1s mixed with 2, so 3 orbitals involved in mixing, and that is why 3 hybrid orbitals you will get. And since 1s mixed with 2, that's why the hybrid orbitals are called sp2 hybrid orbitals. These 3 sp2 hybrid orbitals, this is sp2 hybrid orbitals, are trigonally arranged with an angle 120 degree. I'll show you how the trianguli they are present. So when some atom undergo sp3 hybridization, it will adopt tetrahedral shape, and when the atom undergo sp2 hybridization, then the shape will be triangular and the bond angle will be 120 degree. The unhybridized p orbital lie perpendicular to the triangular plane. Now let's see how the mixing takes place. So first time I'll write the electronic configuration of carbon in ground state. Ground state configuration, you know, 1s2, 2s2 and 2p contain 2 electrons. This is the electronic configuration of carbon in the ground state, 2px, 2py, 2pz. When carbon undergo excitation, then one electron will jump from 2s to 2pz as you have done in sp3. So 1s will remain same, 2 electron. Now 2s contain 1 electron and 2p contain 3 electron, 1 in 2px, 1 in 2py, 1 in 2pz. This is called carbon in excited state. After excitation of the electron, mixing of orbital takes place. Now one s orbital mixed with any two p orbital. I mix the s with px and py. This pz is called unhybridized orbital. You have written the unhybridized p orbital. That unhybridized p orbital is 2pz now. So after mixing, this is called mixing of orbital, which is called hybridization. Then 1s will remain same, it do not involve in mixing. Since s mixed with 2p, that's why you will get 3 sp2 hybrid orbitals like this. These are the sp2 hybrid orbitals, I mean after mixing. And in the mixing 1, 2, 3 electron, since their energies are same, so you have to put the electron single. And this 2pz orbital, since it do not involve in mixing, so it will remain here. This is your 2pz, which is called unhybridized orbital. It also carry 1 electron. Now these 3 sp2 hybrid orbitals, they are trigonally arranged. Trigonally arranged means their structure is like this. one will be present like this. This is one sp2. Another will be present like this, and another will be present like this. And this is called a triangular shape, and they are in planar structure. Everyone contain one electron, and these are the sp2 hybrid orbital of carbon. So these are 3 sp2 hybrid orbital produced. They are triagonally arranged with an angle 120 degree. Here every angle is 120 degree. 120 degree. And this unhybridized 2pz, it will lie perpendicular to the plane. This is your 2pz orbital. It also carry one electron, which is present perpendicular to the triangular plane. So sp2, they are present in plane, and this 2pz, it is perpendicular to the plane. This is your unhybridized orbital. Now you have seen 2pz I have written like this, and the hybrid orbital I have written like this. Do you know the difference? They involve in mixing. S is mixed with P. That's why hybrid orbital shape is like this. But this is unmixing orbital. It do not involve in mixing. As you know, P orbital, when it is in pure form, it has dumbbell shape. That's why dumbbell shape remain here. So P is dumbbell. These are hybrid orbital. Now, if you want to draw structure of ethene, I mean alkene. As you know, alkene contain carbon-carbon double bond. Every alkene undergo sp2 hybridization. I mean, when a carbon is single bonded carbon, it undergo sp3, and when a carbon is double bonded carbon, it undergo sp2 hybridization. So I will draw the structure of ethene molecule, whose formula is C2H4. So in ethene, both the carbon atoms undergo sp2 hybridization because they are double bonded carbon. Now this is one carbon, and here I will write another carbon. This carbon produce 3 sp2, and they are triagonally arranged like this. These are the 3 sp2 of one carbon. Your orbital size should be same. They should be similar in size, because all are equivalent orbital. And this is another carbon. It also contains 3 sp2. One sp2 overlap with that sp2. It produces one sigma bond. This sp2 contain 1 electron. This sp2 contain 1 electron. So in the overlap area, you will get 2 electron. And another 2 sp2. You have to maintain the triangular shape like this. These are another 2 sp2 for this carbon, and these are the sp2 of this carbon. And the unhybrid orbital 2pz, it lie perpendicular like this. So this is your 2pz for this carbon, and this is your 2pz for this carbon. Now this sp2 overlap with this sp2, it produces sigma. Since these two are parallel to each other, that's why when they overlap, they will form a pi bond. 4 hydrogen present, 2 hydrogen overlap with this to produce sigma bond, and another 2 hydrogen overlap with this sp2 for another carbon like this. So ultimately, carbon-carbon produce first time a sigma bond, then a pi bond will be present, I mean double bond will be present. This side one carbon hydrogen sigma bond, this side one carbon hydrogen sigma bond, and this side one, and this is the structure of ethene. And if someone asks you what will be the shape of ethene molecule, it is triangular in shape, and its bond angle is 120 degree. Why 120 degree? Because it undergo sp2 hybridization. So from the hybridization concept, you can find out the structure of the molecule, you can find out the bond angle between the bonds, what are the bond angle, everything you can find out from the concept of hybridization. And you remember one thing, single bonded carbon undergo sp3 and double bonded carbon undergo sp2. Alkene contain double bond, that's why in alkene it undergo sp2 hybridization. Thank you.